بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we're going to talk about logarithmic functions, derivatives. Let f be the function defined on an interval I as f of x is ln u of x. F is continuous and differentiable on I, and f prime of x is u prime of x over u of x. So to find the derivative of a lim function, ln u, the derivative would be u prime of x over u of x. Example 1. All the functions below are continuous and differentiable on an interval I, and the question is to find the derivative of each function. F of x is ln x. So its derivative in this case would be u prime of x over u of x, which is 1 over x, and we are applying the formula. F of x is ln 2x minus 4. So f prime of x, applying the formula, would be u prime of x over u of x, or 2 over 2x minus 4. So pay attention here, we put u of x as it is in the denominator, and then we put its derivative in the numerator. F of x is ln of x squared plus 3. F prime of x, applying the same formula, is 2x over x squared plus 3. Now f of x is 2 ln 4 minus 3x. Well, f prime of x in this case would be 2 times u prime of x over u of x, which is 2 times the derivative of 4 minus 3x, which is negative 3, over 4 minus 3x, which is negative 6 over 4 minus 3x. Remember here, dear students, that we are multiplying ln u by a constant, so for the derivative we leave the constant aside. F of x is 5x minus 3 minus ln x. As you see here, ln x will be embedded in other functions. The derivative of 5x is 5, the derivative of negative 3 is 0, and the derivative of minus ln x is minus 1 over x. Now f of x is x ln x plus 2x. Well, here to find the derivative, pay attention, we have to look at the general form of f of x. In fact, in this case, f of x is of the form u plus v. So its derivative would be u prime plus v prime. We derive each part alone. But in fact, the first part of f of x is also of the form u times v. So its derivative would be u prime v plus v prime u plus the derivative of 2x, which is 2. Let's see the answer. So this is of the form u times v. As I said before, its derivative would be u prime v plus v prime u, and the derivative of 2x is 2. And after simplification, we get ln x plus 3. Part G, f of x is x plus ln x over x. As we did before, we have also to look at the general form of f of x. It is of the form u plus v, so we derive each part alone. And the second part in this case, which is ln x over x, is of the form u over v, and its derivative is u prime v minus v prime u over v squared. Let's see the answer. The derivative of x is 1, and the derivative of ln x over x is u prime v minus v prime u over v squared, where u is ln x and v is x. And remember, dear students, that the derivative of ln x is 1 over x. And after simplification, we get 1 plus 1 minus ln x over x squared. Now f of x is ln of 2x minus 1 over x plus 2. Again, the general form of f of x in this case is ln u. And we know from here that the derivative of ln u is u prime over u. So this is ln u, and its derivative would be u prime over u. You see, this quantity, this whole quantity is represented by u, and this would be u prime over u. Now we try to find the derivative of the numerator here, which is of the form u over v, and its derivative is u prime v minus v prime u over v squared over this quantity, which is 2x minus 1 over x plus 2. Now after simplifications, we get 5 over x plus 2 into 2x minus 1. Application. Also, all the functions below are continuous and differentiable, and the question is to find the derivative of each one. F of x is ln x plus 1. Try to do it alone. So f prime is u prime over u, which is 1 over x plus 1. Remember, this is of the form ln u of x. F of x is ln of 2 minus 2x. Its derivative is negative 2 over 2 minus 2x, which is 1 over x minus 1. F of x is ln x squared plus x. This is also ln u. Try to do it alone. So f prime is u prime over u, which is 2x plus 1 over x squared plus x. F of x is x minus 3 ln x. Its derivative, the derivative of x is 1, and the derivative of ln x is 1 over x, and this is a constant which is multiplied by ln x. F of x is 2x plus 1 into ln x minus x. As you see here, the general form of f of x is u plus v, and the form of u in itself is u times v. So this would be u prime v plus v prime u minus the derivative of x, which is 1. After simplification, we get 2 ln x plus 1 plus 1 over x. F of x is ln x over 2x plus 3. F prime is, this is of the form u over v, and the derivative of 3 is 0. So this is u prime v minus v prime u over v squared, which is 2 minus 2 ln x over 4x squared. And if we take 2 in common up and simplify, we get 1 minus ln x over 2x squared. Now a miscellaneous question. F is a function defined on 0 open plus infinity as f of x is x plus ln x plus 1. Prove that f is strictly increasing on 0 plus infinity. Remember, the sense of variations of a function depends on the sign of its derivative. So to tell whether f is strictly increasing or not, you need to find the sign of f prime of x. Try to work it out. F prime of x in this case is 1 plus 1 over x, and the derivative of 1 is 0. And we know that 1 plus 1 over x is strictly positive because x in this case, pay attention, is strictly positive. And if f prime of x is strictly positive, this means that f is strictly increasing. Now the second part, write an equation of t, the tangent to c at the point L with abscissa 1. Try to work it out and compare your answer to the given answer. We know the abscissa of L, we need its ordinate. Y of L would be x of L plus ln x of L plus 1, which is 2 in this case. So L is the point with abscissa 1 and ordinate 2. We also need f prime of xl, which is f prime of 1. And from f prime of x, we replace each x by 1. We get 1 plus 1, which is 2. And now we write the general equation of the line. Y minus y of L is f prime of xl into x minus xl. We replace to get y equals 2x. Now, application 3. Consider the function g defined on 0 plus infinity as g of x is x ln x minus x plus 2. And the question is to study the sense of variations of g. Try to do it alone, take your time, and then compare your answer. Well, g is of the form u minus v plus w, so we have to take each part alone and derive it. And in fact, the first part of g is of the form u times v. So if we want to find a g prime of x, we begin with the first part, which is u times v. Its derivative is u prime v plus v prime u minus the derivative of x, which is 1, and the derivative of plus 2 is 0. Remember, the derivative of ln x is 1 over x. So g prime of x is ln x. Now we know that ln x is negative from 0 to 1, and it's positive from 1 to plus infinity, and it vanishes at 1. Now let's see this table. We begin by the domain of definition, which is 0 open plus infinity, and as I said before, g prime of x vanishes at 1, so this is 1, this is g prime of x. From 0 to 1, g prime is negative, and from 1 to plus infinity, g prime is positive. Now, negative means that g is strictly decreasing, and positive means that g is strictly increasing. And when x is 1, g of x, if we replace x here by 1, we get 1. Remember, when the question is study the sense of variations, it means we need the whole table, but we don't need to calculate the limits. Now, Rima or Mira, f is a function defined on 0 plus infinity as ln x quantity squared. The question is to find f prime of x. Well, Rima did it as follows. Rima said that f prime of x is 2 into ln x, whereas Mira said that f prime of x is 2 into ln x prime, which is 2 into ln x into the derivative of ln x, which is 1 over x, and this could be written as 2 ln x over x. Now, which method is correct? I think Mira's method is correct, and Rima's method is not, because she didn't multiply by u prime. Thank you.